So in physics we will start new chapter which is electromagnetic radiation. First of all, let's understand where this term electromagnetic come from. First of all, we believed that the light travel in the form of straight line. Then we found out that if we believe light to be traveling as a straight line, then we are not able to explain certain phenomena like phenomena of interference, phenomena of diffraction and phenomena of refraction. So what do I mean by this point based on the MCQs? So for MCQ point of view, if we believe that light travels in straight line, then certain phenomena such as interference, diffraction and refraction cannot be explained. So to explain these three phenomena, we considered that light travel as wave. Okay, that means if we consider light to travel as a wave, then phenomena of interference, phenomena of diffraction and phenomena of refraction can be explained. Now to understand the wave nature, a theory was proposed which is called as wave theory. According to wave theory, the light travels in form of EM radiation, and EM radiation has two components. First component is an electrical component and second component is an magnetic component. That means electromagnetic radiation can also be written as EM radiation, where E stands for electrical component and M stands for magnetic component. Here also electro stands for electrical component and magnetic stands for the magnetic component. So according to wave theory, any particle, or we can say any charged particle, when accelerated, it produces an electric component and a magnetic component. Okay, whenever a charged particle is accelerated, it produces electrical component and a magnetic component. Both of these components are perpendicular to each other. That means electrical component is perpendicular to magnetic component, and both of these components are also perpendicular to the direction of propagation. Like this, here red represent the magnetic component and black represent the electrical component. So electrical component is perpendicular to magnetic component and magnetic component is perpendicular to electrical component, and both the components are perpendicular to the direction of propagation. यहाँ पर एक वेव कुछ इस तरह से propagate कर रही है और दूसरी वेव horizontally propagate कर रही है. Okay, so one wave is like this and second is like this in 3 dimension. Okay, so EM radiation is a 3-dimensional wave. Okay, where one wave is electrical component and second wave is magnetic component. Second, the above electrical component and magnetic component is characterized by wavelength, frequency and wave number. That means each component has its own wavelength, frequency and wave number. We will later understand what do we mean by wavelength, frequency and wave number. For now, let's move on. Energy of electromagnetic radiation is proportional to the frequency of radiation. This is very important point. The energy of electromagnetic radiation is proportional to the frequency of radiation, and it is independent of the wavelength of radiation, we can say, and wave number of radiation. It is only dependent on the frequency of radiation. Next, energy is quantized and called as photon. We quantize the energy and we call photon as the quantized form of energy, or we can also define photon as packet of energy is called as photon. Okay, where energy of each photon is denoted by capital E, where E is equal to h mu, where h is Planck constant, and this Planck constant has a value 6.626 into 10 to the power 27 erg second, and mu stands for frequency, so we can also find out that E is directly proportional to mu. That means energy of radiation is directly proportional to the frequency. It also has relation with wavelength and wave number that we will understand later on, but for now we only need to understand that energy of radiation is directly proportional to the frequency of radiation. And most important point is, all electromagnetic radiation do not require any medium to propagate. Electromagnetic radiation do not require any medium to propagate. इसको आप कंपेयर कर सकते हैं वाटर वेव के साथ. वाटर वेव रिक्वायर वाटर एज अ मीडियम टू प्रोपोगेट, whereas electromagnetic radiation require no medium to propagate. It can also propagate through vacuum. Now we will understand some more point of this wave theory. Continuing with our wave theory, first of all, the value of Planck constant, that means h is 6.262 into 10 to the power minus 27 erg second. Okay, now moving to the next point of wave theory. When a beam of light is passed through a prism, it is splitted into 7 different bands of color, and this phenomena is called as dispersion. So what is dispersion? Whenever a beam of light is passed through a prism, it's split into 7 different band of colors. This phenomena is called as dispersion. So this is beam of white light and this is our prism. Whenever a beam of white light is passed through this prism, it gets split into 7 different bands of colors, which are also represented as VIB, GYOR: violet, indigo, blue, green, yellow, orange and red. Okay, this phenomena is called as dispersion. In simple terms, it is also called as the phenomena of splitting of light. Next, let's move on to the concepts which are related to wave, to the specification of waves. First is wavelength. What is wavelength? Wavelength is defined as the distance between two adjacent crust or troughs. यहाँ पे जो आप C से marking देख रहे हैं, these are called as crust and these are called as troughs. So the distance between two adjacent crust or troughs is called as wavelength. Okay, it is denoted by a Greek symbol called as lambda. It is denoted by a Greek symbol called as lambda. Next, the unit of wavelength is meter, centimeter, or we usually use angstrom. Angstrom is denoted by this. A के ऊपर डिग्री लगाकर इसका सिंबल हम बनाते हैं, where 1 angstrom is equal to 10 to the power minus 8 सेंटीमीटर. ओके, तो इसकी यूनिट अगर बात करें वेवलेंथ की, तो वेवलेंथ की यूनिट इन टर्म्स ऑफ कह सकते हैं लेंथ होती है. लेंथ की यूनिट क्या हो सकती है? किलोमीटर हो सकती है, मीटर हो सकती है, सेंटीमीटर हो सकती है, माइक्रोमीटर हो सकती है. तो इसी तरह से हम लोग इसको डिनोट करते हैं. यूजुअली हम लोग एंगस्ट्रॉम यूज़ करते हैं, वेयर 1 एंगस्ट्रॉम इज इक्वल टू 10 to the power minus 8 सेंटीमीटर. नाउ नेक्स्ट इज वेव नंबर. वेव नंबर इज रेसिप्रोकल ऑफ वेवलेंथ, यानी कि वेवलेंथ का उल्टा कर दो तो हमें मिलेगा वेव नंबर. सो इट इज़ एक्सप्रेस्ड इन टर्म्स ऑफ सेंटीमीटर इनवर्स. मैंने वेवलेंथ में बताया इट इज़ एक्सप्रेस्ड इन टर्म्स ऑफ मीटर, सेंटीमीटर और एंगस्ट्रॉम. सो wave number can be expressed as meter inverse, centimeter inverse and etc. So we usually use centimeter inverse to express our wave number. Next, it is defined as, it is represented or we can say it is denoted by mu bar. Mu bar से इसको denote करते हैं. The symbol of mu bar is this. Now it is defined as the number of waves that can pass through space of 1 centimeter. For example, ये एक 1 centimeter की space है point A से point B तक. I am talking about the total number of waves that can pass through this space of 1 centimeter. That will be called as the wave number. Now we will move on and understand what is frequency and energy of radiation. Moving on to the next parameter, which is frequency. Frequency is defined as the number of waves that can pass through a space or through a point in 1 second. 1 सेकेंड में किसी भी पॉइंट से कितनी वेव पास हो सकती हैं, दैट इज कॉल्ड एज द फ्रीक्वेंसी. ओके, द नंबर ऑफ वेव्स दैट कैन पास थ्रू अ पॉइंट इन 1 सेकेंड इज कॉल्ड एज फ्रीक्वेंसी. इट इज डिनोटेड बाय म्यू. द यूनिट ऑफ फ्रीक्वेंसी इज सेकेंड इनवर्स, यानी कि पर सेकेंड, और hertz, which is also denoted as Hz, capital H and small z. Now, frequency is reciprocal of wavelength. That means frequency is inversely proportional to the wavelength, and we also have a formula where frequency is equal to c upon lambda, where c is speed of light in vacuum. By this relation, we can find that greater the frequency, smaller will be the wavelength. एक कॉन्सेप्ट मैं आपको और बताता हूँ. आपके पास ये 1 सेंटीमीटर की स्पेस है. इस 1 सेंटीमीटर की स्पेस से जितनी वेवलेंथ पास हो सकती हैं उसको हम लोग कहते हैं क्या? उसको हम लोग कहते हैं वेव नंबर. और मैं आपको फ्रीक्वेंसी के केस में कह रहा हूँ कि वेवलेंथ यानी कि वेव की लेंथ, लंबाई जितनी छोटी होगी किसी एक पॉइंट से उतनी ही ज़्यादा वेव्स पास हो जाएंगी. ये एक बहुत ऑब्वियस सी चीज़ है. वेवलेंथ जितनी लंबी होगी, एक पॉइंट से जब पास होना होगा तो मान लीजिए ये A है, ये B है, ये 10 सेंटीमीटर लॉन्ग है. इसको इस पॉइंट से पास होना है, 1 सेकेंड में पास होना है. तो अगर मैं कहूँ कि A to B 10 सेंटीमीटर को पास होना है तो टाइम लगेगा. मान लीजिए एक ट्रेन है, ट्रेन 10 सेंटीमीटर लॉन्ग है, ये एक पॉइंट है, पॉइंट P. इस पॉइंट P से इस ट्रेन को पास होना है. तो अगर ये 10 सेंटीमीटर लॉन्ग ट्रेन है तो ज़्यादा टाइम लगेगा एज़ कम्पेयर टू अगर कोई और ट्रेन 2 सेंटीमीटर लॉन्ग है. 2 सेंटीमीटर लॉन्ग ट्रेन विल पास पॉइंट P faster than the 10 centimeter train. Okay, so same is in case of frequency. Wavelength जितनी छोटी होगी उतना ही ज़्यादा आपका फ्रीक्वेंसी हमें मिलेगा, क्योंकि उतनी ही ज़्यादा वेव पास हो सकेंगी. नेक्स्ट, एनर्जी ऑफ रेडिएशन. फर्स्ट ऑफ ऑल, एनर्जी ऑफ रेडिएशन इज क्वांटाइज्ड and small packets are made which are called as photons. Now, energy of each photon is represented by E, where E is equal to h mu. H is Planck constant, mu is frequency. We also know that frequency is c upon lambda, so we can write that E is equal to c upon lambda. That means E is inversely proportional to the wavelength, and E is directly proportional to the frequency. Okay, so these are the terms which were related to electromagnetic radiation. In next lecture we will study some numericals based on wavelength, wave number, frequency and energy of radiation. Thank you.